When upgrading a 200 amp electrical service to 400 amp single phase for multiple mobile homes, understanding the grounding requirements is crucial, especially with a 3-wire sub-feeder system lacking a dedicated ground. The National Electrical Code, specifically Section 250.32 Exception Number 3, addresses situations where a grounding system may not be capable of handling the maximum fault current. In this context, increasing the service to 400 amps necessitates a grounding system capable of managing a potential 400 amp fault current. The existing 3-wire sub-feeder system without a ground mandates the installation of a separate grounding conductor to each mobile home to ensure safety and compliance. Installing 2 ground rods at each mobile home location and connecting a number 4 American wire gauge conductor to both the mobile home frame and the sub-panel is an acceptable method, and it creates a more robust grounding system and aids in dissipating fault current effectively. The code provides flexibility under exception number 3 of section 250.32 because it recognizes that in certain circumstances, like older installations or specific site conditions, achieving a low resistance ground through a single grounding electrode may be impractical. By utilizing multiple grounding electrodes such as 2 ground rods, the overall grounding impedance is reduced, improving the path for fault current to return to the source and activate overcurrent protective devices, such as circuit breakers. This approach helps to clear faults quickly, minimizing the risk of electrical shock or fire. It's important to ensure proper installation of the ground rods. They should be at least 8 feet in length and driven into the earth so that at least 8 feet of the rod is in contact with the soil. The rods should be spaced at least 6 feet apart to avoid overlapping of their effective grounding zones. The connection of the number 4 American wire gauge conductor to the ground rods must be made with approved connectors suitable for direct burial. These connectors should be corrosion resistant and provide a reliable electrical connection. The conductor itself should be protected from physical damage where it is exposed. When connecting the number 4 American wire gauge conductor to the mobile home frame, it is vital to use a listed grounding lug or terminal that is specifically designed for this purpose. The connection point on the frame should be clean and free from paint or corrosion to ensure a good electrical bond. Similarly, the connection to the sub-panel within the mobile home should be made at the designated grounding bar using a listed connector. The grounding bar should be securely bonded to the metal enclosure of the sub-panel. It is worth emphasizing that the purpose of grounding is not to eliminate the possibility of electrical shock but rather to provide a low impedance path for fault current to flow back to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices, which interrupt the circuit and prevent a dangerous voltage from being present on the metal parts of the electrical system. Without a properly installed grounding system, a fault current could flow through unintended paths such as a person touching a metal appliance, resulting in a severe electrical shock. The size of the grounding conductor is also critical. Number 4 American wire gauge is a common size for grounding electrodes, but the specific requirements may vary based on the size of the service entrance conductors. Refer to the NEC Table 250.66 to determine the appropriate size of the grounding electrode conductor based on the size of the ungrounded service conductors. For example, if the service entrance conductors are 4/0 copper or 250 aluminum, then number 4 American wire gauge copper is sufficient as the grounding electrode conductor. However, if the service entrance conductors are larger, a larger grounding electrode conductor may be required. In addition to the grounding electrode system consisting of ground rods and the grounding electrode conductor, it is also essential to ensure proper bonding within the mobile home. Bonding refers to the connection of all metal parts of the electrical system to the grounding system. This includes metal enclosures of electrical equipment, metal water pipes, and metal gas pipes. Bonding ensures that all metal parts are at the same electrical potential, minimizing the risk of shock if a fault occurs. Within the sub-panel, the neutral conductor should be isolated from the ground bar. This is because the neutral is only bonded to ground at the service entrance. Bonding the neutral to ground at multiple points can create circulating currents and increase the risk of electrical noise. The green equipment grounding conductors that run with the branch circuit should be connected to the grounding bar in the sub-panel. These equipment grounding conductors provide a path for fault current to flow back to the source in the event of a fault on a branch circuit. The equipment grounding conductors should be properly sized according to NEC Table 250.122 based on the rating of the overcurrent protective device protecting the branch circuit. For example, a 20 amp circuit requires a number 12 American wire gauge equipment grounding conductor, while a 30 amp circuit requires a number 10 American wire gauge equipment grounding conductor. When working with electrical systems, it is always recommended to consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and standards. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself from electrical shock. Always de-energize the circuit before working on it and use appropriate personal protective equipment such as insulated gloves and safety glasses. Furthermore, local codes and regulations may impose additional requirements beyond those specified in the NEC. It is the responsibility of the installer to be aware of and comply with all applicable codes and regulations. In summary, upgrading a 200 amp service to 400 amps for mobile homes with a 3-wire sub-feeder system requires careful attention to grounding requirements. Installing 2 ground rods at each mobile home and connecting a number 4 American wire gauge conductor to the frame and subpanel is a viable solution under NEC 250.32 exception number 3. Proper installation and bonding are essential to ensure a safe and effective grounding system. Always consult with a qualified electrician and comply with all applicable codes and regulations. Remember that electrical safety is paramount, and taking the necessary precautions can prevent serious injury or property damage. In addition to the physical installation of the grounding system, it is also important to consider the long-term maintenance and testing of the system. Ground rods can corrode over time, which can reduce their effectiveness. Periodically, the grounding system should be inspected and tested to ensure that it is still providing a low impedance path to ground. One common method for testing the grounding system is to use a ground resistance tester. This device injects a current into the ground and measures the voltage drop to determine the resistance of the grounding system. A low resistance reading indicates a good grounding system, while a high resistance reading indicates a problem that needs to be addressed. If the ground resistance is too high, it may be necessary to drive additional ground rods or replace existing ground rods that have corroded. Another important aspect of grounding is surge protection. Electrical surges can damage sensitive electronic equipment. Surge protective devices, or SPDs, can be installed at the service entrance and at subpanels to protect against surges. SPD diverts surge current to ground, preventing it from reaching sensitive equipment. SPD should be selected based on the voltage and current requirements of the electrical system. They should also be properly grounded to ensure that they can effectively divert surge current. The NEC provides guidelines for the selection and installation of SPD. In addition to grounding and surge protection, it is also important to ensure that the electrical system is properly protected against overcurrents. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the circuit in the event of an overload or short circuit. These devices protect the wiring and equipment from damage and prevent electrical fires. Circuit breakers and fuses should be selected based on the ampacity of the conductors they are protecting. They should also be properly installed and maintained to ensure that they function correctly. The NEC provides guidelines for the selection and installation of overcurrent protective devices. When working on electrical systems, it is always important to follow safe work practices. Always to energize the circuit before working on it and use appropriate personal protective equipment. Never work on electrical systems when you are tired or distracted. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock. Remember, the information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician and comply with all applicable codes and regulations. The National Electrical Code is a comprehensive set of standards that govern the safe installation of electrical systems. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirement. The NEC is available for purchase from the National Fire Protection Association, or NFPA. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It is important to be aware of and comply with all applicable codes and regulations. Local codes and regulations may be more stringent than the NEC in some cases. In addition to ground rods, other types of grounding electrodes may be used, such as ground plates and underground metallic water pipes. Ground plates are typically made of copper or steel and are buried in the earth. Underground metallic water pipes can also be used as grounding electrodes if they meet certain requirements. The NEC specifies the requirements for using different types of grounding electrodes. The choice of grounding electrode will depend on the site conditions and the local codes and regulations. In some cases, it may be necessary to use multiple types of grounding electrodes to achieve a low resistance ground. When using multiple grounding electrodes, they should be bonded together to create a common grounding system. The bonding conductors should be sized according to the NEC. The purpose of bonding the grounding electrodes together is to ensure that they are at the same electrical potential. This minimizes the risk of shock if a fault occurs. In addition to grounding the electrical system, it is also important to ground metal structures such as fences and sheds. Metal structures can become energized if they come into contact with a live electrical wire. Grounding metal structures reduces the risk of shock if someone touches them. The grounding conductors for metal structures should be sized according to the NEC. They should also be properly connected to the metal structure and to the grounding system. When grounding metal structures, it is important to avoid creating ground loops. A ground loop occurs when there are multiple ground paths between 2 points. Ground loops can cause circulating currents that can interfere with electrical equipment. To avoid ground loops, it is important to use a single-point grounding system. In a single-point grounding system, all grounding conductors are connected to a single grounding point. This eliminates the possibility of circulating currents. The single grounding point should be located as close as possible to the service entrance. When installing electrical systems, it is important to use high-quality materials and workmanship. Poor quality materials and workmanship can lead to electrical failures and increase the risk of shock. All electrical materials should be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. Listed materials have been tested and certified to meet safety standards. Electrical work should be performed by qualified electricians who have the knowledge and experience to install electrical systems safely. In addition to proper installation, it is also important to maintain electrical systems properly. Regular maintenance can prevent electrical failures and extend the life of electrical equipment. Maintenance should include inspecting wiring, tightening connections, and testing overcurrent protective devices. Any damaged or worn component should be replaced promptly. It is also important to keep electrical equipment clean and dry. Dust and moisture can cause electrical failures. When cleaning electrical equipment, always de-energize the circuit and use a non-conductive cleaner. By following these guidelines, you can help to ensure the safety and reliability of electrical systems. Remember, electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock. Always consult with a qualified electrician and comply with all applicable codes and regulations.